Okay. Now second part of the question here, again we have to find the value of VID that causes Q2 to conduct. The transistor Q2 will conduct the entire current. At the same time, Q1 will be off, and corresponding to this value, we have to find VD1 and VD2, just opposite. So again, just we can go to the result of the previous derivation. What we have found is this is the another extreme value, that is negative extreme value of your differential input voltage, that will cause Q2 to on and Q1 to off. So this is the negative VID. The negative VID will cause the transistor Q2 to on and Q1 will be off. That means the entire current I will be now flowing through Q2. Meanwhile, the Q1 is off, means zero current is flowing through Q1. So the extreme value is given by minus root 2 VOV. We already find out the value of VOV 0.316. So multiply by minus root 2, answer is 0.446 volt. So in this particular case, Q1 is off and Q2 is on. Q1 off means the drain current ID1 is 0 and the drain current ID2 is your maximum current, the entire current 0.4. So based upon these two currents, we will be calculating VD1 and VD2. VD1, you know the equation VDD minus IDRD. Since Q1 is off, there is no current through Q1. No current through Q1 means the drain voltage is 0. That is the resistance drop is 0. Okay, there is no current through Q1 means the drop across RD is 0. So this term becomes 0. So only term left out with this VDD, which is equal to 1.5 volt. At the same time, what is VD2? VD2, you have maximum current. So maximum current means you will have a drop. So this much drop you have to subtract. ID is 0.4, RD is 2.5. So this much drop you have to subtract from the VDD. So answer is 0.5 volt. Understood? So just observe the two cases. So one case was Q1 was on, Q2 was off. The second case was Q1 was off and Q2 was on. Okay. So by observing the output voltage, it is obvious that here VD1 is, first case VD1 is 0.5, VD2 is 1.5. So what about the differential output? What about the differential output? You know, this is a differential amplifier. Differential amplifier means output is double-ended. It is not single-ended. Double-ended output means we are going to take the difference between the output of two terminals. So one probe will be at Q2, the other probe will be at the drain of Q1. So the output voltage is nothing but the drain voltage of Q2 with respect to Q1, that is VD2 minus VD1. So you have to subtract these two voltages to find the final output. So what is the output actually? It is VD2 minus VD1, that is 1.5 minus 0.5, that is 1 volt. Understood? So for first case, you will have a 1 volt output. What is the first case? Q1 on, Q2 off. In that case, you are expecting 1 volt as the output. At the same time, you can go and check for the second case, that is Q2 on and Q1 off. There also we are getting 1.5 and 0.5, but the thing is, it just become reverse. Now find the output here. What is the output? Output is VD2 minus VD1, that is 0.5 minus 1.5. So 0.5 minus 1.5 is minus 1 volt. So this is the actual output range that you have got in this case. Okay. So what is the range of differential output voltage? It goes from plus 1 volt to minus 1 volt. Understood? For the first case, it was plus 1 volt. The second case was minus 1 volt. You got as the output. So recall the third question. What was the third question? You have to find the corresponding range of the differential output. Differential output means VD2 minus VD1. So in the first case, you got plus 1 volt. In the second case, you got minus 1 volt. So the differential output is ranging from plus 1 volt to minus 1 volt. Okay. Again, I am telling, don't try to play on the screen. So this was a numerical problem. So any doubts means you can ask. You want me to explain once more? Any doubts? I'll explain. See, the problem is to find the value of VD1 and VD2 for the two different cases. First case was you have to steer the entire current through Q1. At the same time, the current through Q2 is 0. Okay. So for that, what you have to do, you have to set an appropriate value of VID. That extreme value of VID we have already derived yesterday. It should be between root 2 VOV and minus root 2 VOV. So if you can keep VID as root 2 VOV, you will be able to steer the entire current through which transistor? Through Q1. So that will able to get maximum current through Q1. So the current through Q1 will be 0.4 milliampere. At the same time, current through Q2 will be 0. So based upon that, you can calculate VD1 and VD2. Once you calculate VD1 and VD2, the difference between those two values is the exact output voltage. That is 1.5 minus 0.5 is 1 volt. Similarly, second case, you have to switch on Q2 and Q1 off. So for that, you have to steer the entire current through Q2. For that, you have to make VID negative root 2 VOV. Okay, so you find negative root 2 VOV, that is approximately equal to minus 0.446 volt. So this particular voltage is enough for the transistor Q2 to remain in saturation and Q1 remains in off condition. So the entire current ID2 will be equal to ID 0.4. At the same time, ID1 equal to 0. So based upon that, we are calculating VD1 and VD2. So once you calculate VD1 and VD2, just subtract those drain voltages, you will get the final output. So that is 0.5 minus 1.5 is minus 1 volt. So the range of output is from plus 1 volt to minus 1 volt. Hope you have understood. Any doubts? Now coming to the next topic, large signal operation. Okay. So far in this module, we have done two different modes of operation of the amplifier, differential amplifier. One is the common mode operation and the second one is differential mode operation. Also, we have derived the range of operation also. VCM max, VCM min, we have derived. Again, VID max and VID min also we have derived. So care should be taken to give the input to in between these two ranges so that the amplifier will operate in its corresponding modes. Now we'll be dealing with the larger signal operation. Large signal operation means here you are giving a large signal, input signal VGS1 and VG2, so that we have to derive the transfer characteristics of this amplifier. Okay, we are assessing the transfer character. Transfer character means how the current is varying with respect to voltage. Means input voltage. What is the input voltage actually? How many inputs are there for this particular version? Anybody? How many inputs are there? Sharath, how many inputs are there for this particular amplifier? How many inputs are there for this particular amplifier? Sharath, TP. See, try to respond to my questions, then only you will be able to get the attendance. I'll be cross-checking the participants of this Zoom with respect to that Google form. Okay, and also you should be able to respond to my questions also. Otherwise, I won't be able to know whether you are sitting or whether you are doing some other business or whether you are participating in the class. Anybody? How many inputs are there for the differential amplifier normally? How many inputs are there for the differential amplifier? Only one or two or three, four? What is the answer?
Two, sir.
Okay. See, your response is very weak. You have to respond to my questions. Then only this class will, because we are taking so much pain to arrange classes for you. And if you're not responding, means we won't be getting enough energy also. So try to respond to my questions. Okay. So here you have given two inputs, VG1 and VG2, which is given to the differential amplifier for the amplification. You know the working of the differential amplifier. It will be amplifying the differences between the two inputs. Okay, that is VG1 minus VG2. So this difference between the two inputs is nothing but your VID. And here in this large signal operation, we are trying to derive the transfer cara. Transfer cara means how the current is varying with respect to the input voltage. You know the current is nothing but ID. So that drain current ID1 and ID2, there are two outputs current drain ID1 and ID2. So those two output currents, how it is getting varied with respect to your VID. What is VID? VID is a differential input. Differential input is nothing but VGS1 minus VGS2. Okay, so with respect to change in VID, when VID becomes 0, what will happen? When VID becomes much more positive, what will happen? When VID becomes the extreme value root 2 VOV, what will happen? So that we are trying to plot in a graphical manner. So that is what is the importance of large signal analysis of a differential amplifier. Got the objective? Okay, so in this large signal analysis operation, we are trying to draw the transfer cara. To draw the transfer characteristics, we have to get a relation between the drain current and the input voltage. Actually, what is the input voltage here? It is not VGS1, it is not VGS2. It is actually the difference between VGS1 and VGS2, that is VID. Understood? So based upon this VID, how that is changes in VID should reflect the changes in corresponding currents. So that change in ID with respect to VID will be plotting in a graphical way. That is what is known as transfer characteristics. Based upon that transfer characteristics only, we are going to plot all these things. Okay. So first we will have an equation for ID1 and ID2. So to perform the small signal, large signal analysis, we have to assume that both the transistors Q1 and Q2 are remain in saturation and they are matched devices also. Okay, and the body effect and the channel length modulation effect is being neglected for the simplification. So there is no body effect as far as there is no channel modulation effect. You know what is body effect, isn't it? That is apart from gate, source and drain, you are having a body. That is body is nothing but your substrate. So normally the substrate will be held tight to the source. Okay, the source and substrate, they will be tied together. Okay, if not, it is not having the body effect. If the body effect is to be considered, means it will not be tied to the source, it will be tied to some other voltages or some other reference point like ground. That is what is known as body effect. Understood? Normally, if there is no body effect, means the source will be tied to the substrate. So that and all you have studied in the first module or second module. So I don't want to explain that anymore. So for this analysis, we have assumed that there is no body effect for the transistor. There is no body effect means the source have been tied to the substrate or body. Okay, now these two equations, you know it very much. It is nothing but the equation for drain current with respect, that is in terms of VOV, that is overdrive voltage. You know that overdrive voltage is nothing but the difference between VGS and VT. You have two transistors, so you should be able to write the equations for two drain currents, ID1 and ID2. So ID1 is half K n dash W by L into VGS1 minus VT the whole square. ID2 is half K n dash W by L into VGS2 minus VT the whole square. All these notes I have uploaded in Google Classroom, but only 4 students have registered in the classroom as of now. Why you people are like this, I don't know. Okay, so please go and I have registered. I have given the password 2 days before, but you didn't log in at all. Daily basis classes, I am recording the videos and putting the videos in the Google Classroom. So whenever, if at all you are not viewing this particular class or not attending the class, still you will have some opportunities to understand those by downloading those videos. Okay, so make use of that Google Classroom, get into the Google Classroom. At the same time, you have to submit your assignments also before Saturday. No excuse, somehow you have to manage. Okay, don't say like small children that you are not getting, you are not accessing A4 sheets or not. Somehow you can able to get. Okay, if you are really interested to write, means if you want, means you will do somehow. So somehow you write, scan it and upload as a PDF in the Google Drive. So an assignment folder has been created, you can upload that. Okay. Okay, so for as of now, we have written two equations for the drain current ID1 and ID2 in terms of VGS1 and VT. Next thing what you have to do is just take square root on both sides. Okay, this is very simple derivation, but it is a little bit lengthy. Okay, but it is going to be very important for your SCE also. So be careful. That is only if you practice, write and practice, then only you will be able to get the result. Okay, the derivation output. So just try to understand the steps and listen carefully. So once after you have written these two equations, next thing what you have to do is just take square root on both sides. Why you want to take square root is I just want to remove this square. So I have taken square root on both sides for equation number 1 and 2. That will yield equation number 3 and 4. Now what I'll do is I'll subtract 4 from 3. 4 from 3 means 3 minus 4. So root ID1, what is LHS here? LHS is root ID1 or here it is root ID2. So square root of ID1 minus square root of ID2 is equal to, these two are common factors which you can take an outside. So square root of half K n dash W by L can be taken outside. So inside the bracket you will have VGS1 minus VT minus VGS2, minus into minus becomes plus because you are subtracting 3 minus 4, isn't it? So there will be a minus or here and minus here along with VT. So those two minus, it becomes plus. So as a result, these two VTs will cancel and you will have VGS1 minus VGS2. Actually, what is VGS? VGS means it is potential difference between gate and source. So while writing VGS, you can write VGS, VG1 minus VS. Why you are not writing VS1? or vs2 here. You're writing it like vs. Why it is so? You're not specifying like 1 2 in the case of source terminal. Why it is so? Anybody? Hmm? Why? At least type a message. If you're not willing to speak, at least type a message and send. Why you're not specifying 2 for the source terminal? Okay, I'll wait for your answer and I'll be continuing. So try to tell that answer now. Okay. Yeah, because common source, Sharanya. Okay, Sharanya. That is, you have shorted the two source terminals together because source is common, isn't it? Source is common, so at least one have responded. Thank you so much. So the two sources have shorted means they are having same voltages. So no need to specify like VGS1 or VGS2. Just you put VG 1 and VG2 and the source voltages you can cancel each other. So VGS1 is VG1 minus VS. Similarly, what is VGS2? It is VG2 minus VS. So that minus of minus will become plus because here you have minus and here also you have minus. So that minus becomes plus. So I cancel that. That is VG1 minus VG2. You know what is VG1 minus V2? VG2. What is VG1 minus VG2? It is nothing but the difference between the two inputs. What is that? Difference between the two inputs is nothing but your input differential voltage, that is nothing but VID. Okay, so here this particular term you can now replace with VID. So the equation number 5 will go like this: root of ID1 minus root of ID2 is equal to square root of I by 2 kn dash W by L into VID, because VG1 minus VG2 is now VID only. Understood till equation number 7? You have any doubts? So what and all I did is, first, I wrote two equations for ID1 and ID2. Next thing, what I have done is, I just made a square root on both sides, then subtracted two equations each other, take common from the right side, then replace VGS1 and VGS2 as VG1 minus VS and VG2 plus VS, so that VS will get cancelled. So the remaining answer in the bracket will become VID. So that is equation number 7. Now what you will do is, you know that the two drain currents of the two transistors, they will accumulate at the source and it forms I, isn't it? This ID1 and this ID2, whatever it is flowing through the two transistors, they will get summed up together to form this I. So you can write ID1 plus ID2 is equal to I, that is equation number 8. Understood? Now keep this equation as such. Now what you will do is, to remove the square root, I'll be squaring equation number 7 on both sides. Okay, so square root of ID1 minus square root of ID2 the whole square is equal to this term. It will become, square root can be removed because if you square on both sides, the square root will go and remaining term is VID square. VID will become VID square once you square this equation on both sides. Now what you will do is, you expand this A minus B whole square, that is ID1 a square, root ID1 square is ID1, a square plus b square, that is root ID2 square is ID2, minus 2ab, that is minus 2 square root of ID1 square root of ID2, equal to half kn dash w by l into VID square. That is equation number 9. Understood? What you have done here is just expand this algebraic equation a minus b whole square. Then see, I need this particular equation with only one variable. That is, here you have two unknowns ID1 and ID2. So I don't want the second variable. I have to replace the second variable in terms of ID1. So what I'm going to do is, I'm going to convert this ID2. Okay, so put 8 in 9. So here ID1 plus ID2 is nothing but I. You know the value of I also. So it is very much simple that you can replace this sum of ID1 and ID2 with I. Okay, so this term it will be I and it just got simplified like this. You have taken I to right side, that is equation number 10. Here also you are having two variables ID1 and ID2. So again I am trying to replace ID2. ID2 is nothing but I minus ID1. Okay, so I just want only one variable in the equation number 10. So first what I have done is, I just expanded this a minus b whole square form, and then I found a term id1 plus id2 that I just replaced with capital I, that is total current I. Then I found two variables in the equation, out of which I just substituted the second variable, that is id2, with respect to id1 from equation number 8, that is I minus id1. So substitute 8 in 10. So the equation will become 2 square root of id1 square root of, instead of id2 you have I minus id1, equal to, right side of the 10th equation can be written as such. So only thing what you have done is just replace this id2 like I minus id1. Again I have to remove this square term, I mean root term, so I just squared on both sides. Okay, I want to remove the square root term, so just I squared on both sides. So 2 square 4, this root has been removed by squaring, so it will become id1. Again this square root has been removed, so it will become I minus id1 equal to I minus half k n dash w by l vid square the whole square, because we are trying to square the both sides by removing the square root. Okay, now you will expand this equation, open the brackets. So 4 id1 I minus 4 id1 id1, what is that, minus 4 id1 square, equal to I minus half k n dash w by l vid square the whole square. Next thing what you will do is, you will take all these terms to left side. You will take all the three terms to left side equal to 0. Okay, because you want to make it as a quadratic equation. Fine. So I just took all those terms to left side, and I just arranged it by taking minus outside. So this will become positive, this will become negative, again this will become positive. So this is a quadratic equation of the form ax square plus bx plus c equal to 0. Here x is a variable ax square, so x is id1. Okay, again here b is 4i, here a is 4, ax square, so a is 4, b is minus 4i, and c is the entire constant value. All these are constant, there is no change for all these, so it is constant. So a, b and c you know. Now you can find the equation roots of a quadratic equation by the conventional formula, that is minus b plus or minus root of b square minus 4ac by 2a. So minus of, what is minus b here? id1 is a variable, id1 is x here. So along with id1, which is a term, it is 4i. So sorry, minus 4i. So minus 4i is your b. So minus 4i plus or minus root of b square. B square means minus 4i the whole square. Minus 4i the whole square is 16i square, minus 4 into a into c. 4 into a is 4. So 4 into 4, 16, into c means this entire term. So that entire term I have written here, whole divided by 2 into a. 2 into 4, it is 8. Very clear now? Just I have applied the quadratic equation solution, that is roots of the quadratic equation I have applied. Then what I'll do is, I'll put this a to two terms. You have two terms here. One term is 4i. This is 4i, and the square root also I'll be applying this 8. To the square root also I'll be applying this 8. So what will happen to the square root, I mean to this 8, when it comes inside the square root? It becomes root of 64, because root of 64 is 8, right? So what I'll do is, I'll put this 8 inside the square root so that it becomes whole divided by 64. At the same time, this 8 is also applicable for this 4i. So minus of minus, it becomes 4i. 4i by 8 is I by 2. Okay. So minus you cancelled. So 4 by 8 is 2. So I by 2 plus or minus square root of this entire term whole divided by 64. You got this now? Root of 64 is nothing but 8. So you have to replace this 8 by taking this 64 inside the square root. Okay, so next step is, again you split the 64 among these two terms, because here in the square root you are having two terms. So I would like to split this 64 to first term as well as second term. So it will go like this. Now what is 16 by 64? It is 16 by 64 is common in both the sides, so you can take 16 by 64 common. So it will go like this. Now root of 16 by 64 is 4 by 8, that is 1 by 2. Okay, so root of 16 by 64 I just put like 1 by 2. So this square root is applicable to this particular term only, so that I have mentioned here. Now I will simplify, just max simplification, mathematically simplification, that is just I'll open the bracket. Again you will expand this as a minus b whole square. So I by 2 plus or minus 1 by 2 square root of I square minus of, you expand this a minus b whole square, you expand, So a square, that is I square minus 2ab. So 2 into I into half. That 2 and this half will cancel. So only the remaining term is I into k n dash w by l into VAD square plus b square. B square means this will become 1 by 4 k n dash w by l into VAD square the whole square. Okay. So this is b square. B square means 1 by 4 into, again for this you have to put as whole square, that is k n dash w by l into VAD square the whole square. So what I did is I just expanded a minus b the whole square term. This is a square term. This is 2ab term. This is b square term. So a square minus 2ab plus b square. Then I'll take this minus sign inwards and simplify. Okay. So I'll take this minus sign inside and simplify. Open all the brackets. So I square will gets cancelled. So the remaining term is I by 2 plus half square root of, these two are the left terms. So there you can take I as common. Sorry, kn dash w by l into VAD square is common. See, these two terms are common here. Kn dash w by l VAD square. Here it is kn dash w by l VAD square. The whole square is there. So one term can be taken outside. So the remaining term here is I minus the other term. Now what I'll do is this square root I'll be putting to all these terms separately. So square root of kn dash w by l, square root of VAD square. What is square root of VAD square? It is VAD. Then I'll take I outside. If I take I outside means here it will be 1, isn't it? And here there should be more I because there is no I. So I have to divide I in the denominator. So I'll take I outside, and that to that I also you put the square root. So square root of I into square root of 1 minus the remaining term. Now just rearrange here. How I'm going to rearrange here is I divided by, see this 4 into this kn dash into w by l I'll put in the denominator. Okay. And this 4 I will take to the numerator. So VID square by 4 I can combine together in such a way that it becomes VID by 2 the whole square. VID square by 4, I can put it in a single term, that is VID by 2 the whole square, whole divided by I divided by this you can put in the denominator, that is kn dash into w by l. Now similarly you will get ID2 also. So now I need to show that step. What is ID2? That is quadratic equation second root. There are two roots now, ID1 and ID2. So the second root is ID2. ID2 can be written as I by 2 minus this value, because or else you will get you can write I minus ID1 also, because the total current is I. ID2 is nothing but when you subtract ID1 from the total current, you will get ID2. That is simple way. Okay. You have the total current capital I. So that capital I minus this particular current will get you the value of ID2. So no worries. Okay. Just you subtract, you put a minus sign over here instead of plus. The remaining terms are all same. So what is the difference here? Only you put a minus sign in this term instead of this plus term. That is the only difference between ID